Hey everybody, Mr. Bells here. This is our Precalc A video for section 2-7 and 2-8. It's on rational equations and polynomial inequalities. If this is the 2021 school year, I know that this kind of got rushed through a little bit because of some snow days and the whole COVID stuff going on. So please pay attention to this. Make sure you watch this as those things come up. If it's another year, hopefully we're going strong with everything and we'll be all good. So again, 2-7 and 2-8 out of the pre-calc stuff. Here are our things. So we're going to start off with a problem just like this. And what I have right now, again, if I looked at these individually, this x would be a line, right, at a 45-degree angle. 21 over x is one of those reciprocal functions that looks like that with the curvies. And of course, 4 is just a constant that goes across. So I'm adding a line with a rational function, trying to see where it flat lines out at 4, where it crosses over there. So what I'm going to do right now is I'm going to try and solve this algebraically before I look at it graphically. So everything that you see here today, or I think most of the stuff that you see here today, is going to be non-calculator based, just common algebra skills. So our rules right now with solving these rational equations is to be able to get rid of anything in the denominator. So in this case, I have a 1 for this in the denominator, 1 for this in the denominator, and an x. So I'm going to multiply this entire equation by x. When I do that, and I distribute to all three of these things, I'm going to get x squared minus 21 equals 4x. I know that that's a quadratic equation. I want to set it equal to 0, not equal to 4x. Set it equal to 0, and maybe I can factor it. So x squared minus 4x minus 21 equals 0, which means my factors are then x minus 7 and x plus 3. Therefore, my solutions are 7 and negative 3. I'm good with that? Now I'm going to take those 7s and those negative 3s, and I'm going to plug them back into this original problem and make sure that it does work. And you can see 7 minus 21 over 7 is 3. 7 minus 3 does equal 4. Check mark. That one does work for 7. Negative 3 here, so negative 3. And then negative 21 over negative 3 is positive 7. So negative 3 plus 7 does equal 4. Both of those do work. And that one's done. I come down to problem number 2, which I have a few more things on this. I'm going to go ahead and distribute by x minus 8 on each one of these things again. To be able to get rid of my denominators, x minus 8 times x becomes x squared minus 8x. X minus 8 times 9x. Well, look, because this is already downstairs and that one's upstairs, those two cancel each other out, so I don't need to distribute that. I can just put the plus 9x. And then likewise, that will cancel that out, and I'll get equal 72. I have another quadratic, and I get x squared plus x equals 72. Set it equal to 0. X squared plus x minus 72 equals 0. Factors of 72 are 8 and 9. Look at that. Isn't that nice? And that would be, looks like a x plus 9 and an x minus 8 equals 0, which means my solutions are negative 9 and positive 8. Yay! And we're all good with that, yeah? However, look. This 8 right here, if I plug that up into my original equation, that would give me a 0 in the denominator, so I know that that is actually considered an extraneous solution. And it's something we want to know about, but it doesn't work in my original problem. If I was to graph this, I cannot learn that bit of information. I can only learn that information from doing this algebra. Okay? Negative 9 actually is real. It will work. If I plugged it in there, I would all work out. Okay? Next one. Here, now I have multiple things that I have to be able to do. Again, I want to kill off my denominators. So I need to multiply by an x, and I need to multiply by an x plus 3. And if you're in a situation on any of these ones that are up here and you've already heard this stuff in class, one of the things I suggest while watching the videos is try the problem before I even explain it. Again, if you've seen this stuff in class. If not, follow along with what we're doing. So here we go. When I do those two terms, and I hope we're understanding that x times x plus 3 is x squared plus 3x, so I don't need to repeat that denominator again. So I do these two to this first one. This x kills this x. So I only have 4 times the x plus 3. So I'm going to have 4x plus 12. Here, the x plus 3 kills the x plus 3. Do you see that? So I have an x times an x, so an x squared, so plus x squared. And then equals, and since x times x plus 3 is x squared plus 3x, that kills that off. I get 9. Set it equal to 0. X squared plus 4x plus 3 equals 0. X plus 3 and x plus 1 equals 0, which gives me negative 3 and positive 1. Yay! So think for yourself right now. Either one of those two things an issue in my original problem. Ding, ding, ding. Jeopardy theme song, right? So hopefully you said this. So negative 3, if I plug that back in, that gives me a 0 in the denominator. That is not an acceptable value in the original problem. So negative 3 is extraneous. And positive 1 is real. If I did plug it in, it would work in that original equation. So again, there are your two solutions. Over here, so now I've already got a quadratic divided by a linear, and it says that it's equal to 0. I'm like, ooh, what do I do here? Well, if it was equal to 2, I would multiply both sides by x plus 3 to get it out of there. But if I multiply both sides by x plus 3 to kill off this denominator, what happens to over here? There's nothing left. So what that means is, if I know that I have a polynomial that's going to equal 0, well, the only way that that could be true is if I had 0 divided by something, whatever that is. So I just need to look for the zeros of the numerator to solve this problem. Well, that, of course, is x minus 7 and x plus 2. Is that okay? Which means 7 and negative 2 are my two solutions to this equation. Now, just like all of these that I've said have worked, we're going to actually try it on this one. So go ahead and try 7. So I plug 7 into the denominator. Would you agree that I get a 10? I plug 7 into the numerator, and I get 49 minus 35 minus 14. Negative 35 and negative 14 is negative 49. 49 minus 49 is 0, and 0 divided by 10 equals 0. Check mark. That works. So one more time, if that went a little fast for you. If I have this division problem, this rational equation equal to 0, the only way it can equal 0 is if the numerator equals 0. So I'm looking for factors of the numerator that give me 0. I simply set the factors equal to 0 and I get the opposite, 7 and negative 2. I check both of those and it will work, even though I only showed you one. Is that okay? Here we go. This is in section 2.8. This is on polynomial inequalities. And what I want to do is I want to be able to graph this, or I want to know when this polynomial, for instance, is positive above the x-axis, negative below the x-axis, or 0 where it actually intersects. So what I'm going to do is I'm going to go ahead and find those actual key points where they touch. You can see that I have it happen at 1, 2, 3, 4, 5, 6, negative 6. At positive 3, 1, 2, 3, positive 3, and at negative 4, 1, 2, 3, 4, at negative 4. And hopefully you guys remember this stuff. When we talked about what things do here, multiplicities, I know at positive 3 it has to bounce, right? Because it's squared, it has to bounce. Because this x, and this x are all positive, my end behavior of this x to the 4th polynomial means that it has to go up when it leaves this. So if it bounces, it has to go like this. And then it must go up. I don't know what it does up here, but then it must come back down and then go back up again. Again, if it's a degree 4 polynomial with a positive leading coefficient, the end results have to go up. Gosh, I'm so sorry. It was so not on my screen. I hope the video's better as we went through that. So that goes up there and there. So if I want to know where is it positive, where is it positive? Well, it's positive when it's above the x-axis, which are all of these things. What's positive? So I would say that it's positive from negative infinity to negative 6, right? It's not equal to 0 there. from -4 to 3, and from 3 to infinity. That's when it's positive. Where is it negative? Where is it negative? It's only negative in this range right here. This is where it's below the x-axis. So it's negative from -6 to -4. And where is it equal to 0? It's equal to 0 at those 3 points. At -6, at -4, and at 3. Okay. Maybe I should scratch those out. It's not really interval notation on that. I don't want you to think it. Those are my zeros, -6, -4, 3. Okay, so seriously hope this didn't suck on all of those explanations. I'm going to leave it here just so that you guys can see that. Maybe you can take a picture of it and you can go back through and you can kind of, just in case that video was off a little bit because of the paper, take a picture of that, and then take a picture of that, so you have it all where you can see it, and you can go back if you need to and follow along to the audio with this thing actually under the right place. Okay, so let's try one of these ones. Similar thing again. I want to know when x plus 2 times x squared minus 7x plus 12, when is it less than 0? When is it below the x-axis? So what am I going to do? I'm going to go here. I'm going to find out where it actually touches. So I know it touches at -2. And I know that this factors into x minus 3 and x minus 4. Right? So it touches at -2, it touches at 3, and it touches at 4. I'm going to go ahead and plot those points. -2, 3, 4. Okay? Big picture again, big picture on this. This is a cubic function, which means the end result has to be, because it's got an x and an x squared, has to look like this. N behaviors here, N behaviors here, because of the positive leading coefficient, and it's a cubic. I don't care how high it goes or how low it goes right there, I just know that that's what's going on. So if I want to know where is this less than 0, well, it's less than 0 for everything here and everything here. So how do I write that? From -infinity to -2, curve union from 3 to 4. Parentheses, parentheses, no brackets because there's no dash underneath. Okay, leave that there for just a second. And I'll throw one more out here. So now it's like, whoa, I have this thing times a radical. It's like, oh, that's sketching me out. That makes it, I'm not sure. Well, I'm going to find out again where it equals 0 and then just look at the situations from that. So where does it equal 0? Well, this one equals 0 at 5 halves. So 1, 2, 3. There's 2.5. And then I go, well, where would this thing equal 0? This thing would equal 0 at -6. 1, 2, 3, 4, 5, 6. Sweet. So instead of doing the little graphy thing, what we've done before with multiplicities or talking about those types of things, I'm going to do this one with the sign chart. With the sign chart. We should have done this in class a little bit here. So I know that everything to the right of this is either above or below. Everything between these is either above or below. And everything to the left of this is either above or below. I just need to find out what it is in terms of this problem. So, first thing I'm going to do is I'm going to check this range right here, from here to infinity. So if that's 3, this is -6, I'm going to check the number 10. Awesome. And I don't want to know the value of it. I don't care what the value of it is. I just want to know, is it positive or negative? So I'll put it in this first expression. When I put 10 into there, I know that I get a positive number. When I put 10 into here, I know that I get a positive number. And a positive number times a positive number is a positive number. So that means this is positive. Check a number in between -6 and 3. We'll go ahead and check 0. So 2 times 0 is 0. 0 minus 5 is negative. 0 plus 6 is positive. So I got a negative and a positive. So that means everything from here to here is below the x-axis. Good deal? And then I'm going to check negative 10. Negative 10 times 2 is negative 20. Negative 20 minus 5 is negative 25. So that's a negative. Put negative 10 into here. Negative 10 plus 6 is negative 4. Square root of negative 4 is, ooh, look at that. We got a new one. That's undefined. That's undefined, which means that everything over here is D and E. Does not exist. So in this case, my solution to this expression, where is it greater than 0, that's pretty easy. From 3 to infinity. Those are the only solutions to this. Again, it's less than 0 here. It's equal to 0 at those two spots. And it doesn't even exist to the left of that. Okay? So I want you to see this because we haven't done a lot of this and we didn't do these in class. So let's go ahead and do a quick little graph of this thing. Y equals clear. Let's go second. Clear zoom 6. We'll get a standard viewing window. And let's put this in parentheses 2. X minus 5. Close parentheses. Radical x plus 6. Just like that. And zoom 6. You're like, whoa, that's freaky looking. It's almost like a weird fish hook, right? So let's go down here, make that negative 20. And you can see, just like we talked about, nothing exists to the left of negative 6. Now, it doesn't touch all the way up there. And again, that's okay. But it stops as the x's get to negative 6. It's negative all the way here. And then greater than 0, everything from that point on. Exactly like we said it was going to be on this one right here. Okay? That actually has it at 5. What? Oh. Did you see that? I forgot my 2 in there. So let me go ahead and do this. Second INS 2, right? If you didn't know how to do that again, second insert 2 to be able to put that in when I go to the graph. Same picture again, except now it actually goes at 2.5, what we said it was going to do right in here, which makes that sloppy. 2.5, 2.5, because it was from that 5 halves. I put the dot there. That was bad. Are we good? Okay, here, last one. What happens when we have a big ol' honkin' question? Big ol' honkin' question. Okay, so I got drains A and B are used to empty a swimming pool. Drain A can empty the pool in 12 hours. Together they can do it in 7 hours. How long would it take drain B by itself? You're like, what the heck is this stuff doing in here? Well, this is a story problem that's going to deal with these rational equations. So let's see if this makes sense. So what is the rate of A? Well, it says that drain A can empty the pool in 12 hours. So it does 1/12 of the job per hour. Correct? Drain B, it doesn't say what it can do, right? So it can do 1x of the job, one unknown amount of the job per hour. Is that okay, everybody? And then if they're both pumping at the same time, then their hourly rate is 1/12 plus 1 over x. Does that make sense? When they're working together. And since they can do it in 7 hours, then their rate per hour plus the rate per hour must be 1/7 of the job in those 1 hours because it takes them 7 hours together. Is that okay? So, looks like that is a rational equation, just like what we've been solving. So what we want to do is we want to try and do the math on this. Is that okay? Hopefully it's okay. So I can do A, I can graph it, or B, I can do some algebra. We're going to go ahead and do some algebra. Now, would it be nice if this 7 and this 12 had common factors, but they don't. So we're going to have to multiply everything through by 84x, which is that denominator times that denominator times that denominator. When I do it to the first one, I should get 7x. When I do it to the second one, I should get plus 84 because the x's cancel out. And when I do it to the last one, I should get equals 12. Is that okay? 12x. I move this x over, 7x from that, so I get 84 equals 5x. And I divide by 5, I divide by 5, and I get x equals 5 goes into 8 one time, 34 left over, that's 5, that's 16, and that's into 80, and 4/5 left over, 16.8. So I did this all without my calculator. I want to try this right now just to make sure I did that right. So on, clear, quit, clear. So 84 divided by 5, 16.8. Feeling good about that? Feeling good about that, yes? So let's talk logic first, because I did that, but I don't know if this makes any sense. So let's go back and talk logically about my pumps here. So if this one takes 12 hours to do it, if the other one took, let's assume, if pump B was 12 hours also, then they would pump at the same rate, right? Yeah, so if they both could do it in 12 hours, then together they could do it in 6 hours. But it actually takes them 7 hours to do it. So it takes them longer than what half of what A is, so that means A must pump out stuff faster. Well, what is my number? My number says that B, right, this is drain B, that drain B takes longer. Hopefully that makes sense. So let's try it right here. Here we go. Ready? Clear. So 1 divided by 12 plus 1 divided by 16.8. Enter. I get that. I'm like, I don't know, is that 1/7? Some of you are like, Mr. Bell's just hit the math frac key. So I hit math, I hit frac, I do that, and I get 1/7, and this right now is what I do, right? I smile like that. Worked. Not only does the number work in my original equation, but logic says that that's what it should be for that pump. Okay? So again, just giving you one story problem in here about solving rational equations, the same type of rational equation stuff that we solved on the first page. Cool. So hopefully that is all good. Again, as always, I am here to help. I can't spin it up on it. There we go, kind of stuck. So if you guys ever need me, please don't hesitate to come in and check in with me. I want this to be successful for you. Again, I'm not going to ever sugarcoat it. This class isn't going to be super easy, and it shouldn't be. You guys should be challenged, and I want you to be challenged. I just don't want you to be overwhelmed. Okay? I'll talk to you later.